started here. Good morning and happy Tuesday. It was kind of nice to have some sun yesterday. I hope you guys were able to get outside and enjoy it. Today we're going to be talking about the last two ways to prove triangles congruent. We're going to do a bit of practice. I just really want to make sure you guys know that I hope you guys are doing well with your homework. And if you guys ever need help with your homework, just to let me know, right? If you find your homework confusing or you're getting stuck, make sure to send me an email, guys, or join my office hours. I would love to help you guys, okay? So please, please, please make sure you're getting your homework in. That's basically your grade, right? It's 80% of your grade is getting your homework in. So please make sure you guys are taking the time to do that. Okay, so what we're going to start out with is we're going to start going over this little warm-up, and then we're going to go into the new two ways to prove triangles congruent. Remember, guys, it's so important to ask questions and participate. So I'm really going to be asking that you guys ask a lot of questions and participate today. If we do that, this could be a really short lesson. And I think people want that, right? We want a short lesson. So let's go ahead and get started with this. So first thing we're going to take a look at is this warm-up. Okay, so taking a look at this first one, we're saying, is the following statement true? So we're saying, is triangle WXY congruent to triangle WZY? So to take a look at that, I'm going to see what I already have here in red. So it looks like with these doubles, I have a pair of congruent sides. And then with these singles, I have a pair of congruent sides, right? So up until this point, we only have SSS and SAS, right? So looking here, I have two pair of congruent sides, right? So I either need to find another pair of sides or another pair of angles. Now, please, please, please remember that you guys, we have a list of all of the rules we're going to use, right? It's that the first day of this trimester, we took a page of notes, right? We wrote down all those properties. So you guys should have that readily available so that you guys can just look. So we don't have any parallel lines. We don't have any X's for vertical angles. We're not going to have linear pairs here. So it doesn't look like we're going to get an angle, right? There's no midpoint. There's no bisector. But one thing that stands out to me is that these triangles share a side. And so what that means that, right, this is reflexive, right, reflexive property. So we're going to have these sides are going to be congruent. So are these triangles congruent? WX goes with WZ, yep, and XY goes with ZY, perfect. So I'm going to say yes by SSS. Okay. We also had to use that reflexive property. Are you guys feeling better about reflexive property? How are we doing there? You guys feeling better about using reflexive property? We've been really using it a lot, right? Yeah. Hey, oh my gosh, you guys are already participating. Thank you for responding. I appreciate you guys. So, and again, if you, I appreciate that. If you turn in your homework late, please send me an email. If you guys tell me in class, I really do have the best intentions to remember, but between now and the end of the day when I'm done teaching, there might be a lot of student conversations. So please just shoot me a quick email saying, hey, I turned this in. That's all it takes. Be like, hey, I'm in your fourth period. Turn this assignment in. Thank you. I appreciate that. All right, cool. So reflexive property, we're getting to use this. This is SSS. So even though it didn't give us all three, right, we can add in one there. Now, in this case, it does give me three, right? So it gives me a pair of angles, it gives me a pair of sides, and a pair of sides. Though we have to be careful, right? So this one, we want to think it's SAS, right? But remember, the angle, just like it says here, the angle has to be in the middle. It has to be an angle sideways. You guys remember that, right? That's a bad joke. But is this angle in the middle? If I were to read these out either clockwise or counterclockwise, right, I would go ASS. Oh no, that's a bad word, right? Or if I was to read it the other way, I'd go SSA. right? Which is just ass backwards. Okay, so if the A, right, if the A was gonna be in between the sides, the angle would have to be here and here, right? Do you see how if I cover that up, see how the angle, those angles would be in between the sides, right? You see how that's an angle sandwich, how both the sides touch that angle, right? Only one side touches this angle, so this angle is not between those sides. So if I were to read this in either clockwise, thank you for sending the email, I appreciate you, thank you. So if you read this right clockwise, it would be angle side side, or if you read it counterclockwise, it could be SSA, right? But the idea is that the angle is not in between. So we can't use ASS and we can't use AS backwards. Okay, does that help out? I put this problem in there, guys, because I knew we would have issues with this. Was that helpful? Does anybody have questions about that? Order matters. So I would say no. And I would say not enough information. Oops. Not enough information. So does anybody have questions about that part B? Right? So we do have three pieces, right? We have a pair of A's, two pairs of S's, but they're not in the right order. And the order is super important. The A isn't in between the S's. Does anybody have questions about that or concerns? A lot of people replied that they were doing well with the first one. Does anybody have questions about the second one? When no one responds, it makes me really worried that my feed isn't working. Are we doing okay with this? Does anybody have questions? Thank you for that response. Right? So again, I really put this one in here because I knew people would say, "Oh, it has all the right parts, it must be congruent." But the parts have to be in the right order. So again, you want to do things either clockwise or counterclockwise. It doesn't matter which way you do it. And see what it spells, right? Order matters. So again, if we were going to use SAS, it would have to be those two angles, right? It would have to be these two angles because those are the angles that are in between the sides. Okay, so which is the right order? So the thing is, the order that we're given, so this is the order that's given, right? It's angle side side. Can we use angle side side? Is that one of the ways to prove triangles congruent? No, it's not. Or if you read it this way, it'd be SSA. So these were, right? This is the order that we have. Right? That's the order in the picture, right? But these are not used to prove triangles congruent. We talked about that a little bit last class was, right? ASS or SSA, right? They're the same things. There's reverse order. They do not prove triangles congruent. And that's what we have here. We have ASS. So do you see how if you go in order clockwise, right? Or you could go clockwise here, SSA. Or you could start here. Now, if you go SAS here, right? Do you see how you're skipping an angle? Do you see how there's an angle here? Right? Do you see, right? So this angle is not in between the sides. So if you tried to go SAS like that, you're skipping a whole angle, right? Do you see how there's an angle here? It's not labeled. So you can't just go SAS like that because you're skipping an angle. So another way to think about it is if it was SAS, it has to be, and that's why I tried to do that first, right? It has to be the angle in between the sides. So if side BA, right, and side CA are your congruent sides, the angle in between them is this. And if you have troubles doing that, just draw those sides out again, right? Right down here below. Right? This is the angle in between the sides. So then if I look down here, right, here are my congruent sides on this shape. Okay, like this. So it would have to be these two angles. And those two angles aren't, yeah, no, I'm so glad. See, this is why you guys should be asking questions because it is confusing. It is confusing and we got to ask questions to help us out. Okay, so that's what's going on there. That's why it's not SAS. Okay, and thank you for asking that question. I appreciate you, and I'm sure there's classmates who are just not asking questions that are are thankful for you too. Okay. All right. So we're going to move ahead. So if you're following along in the book, we're in section 5.6. And we're going to be adding our last two proving rules today. And that is ASA and AAS. Now, I have this weird feeling that you guys probably don't want to take paragraph notes. So what we're going to do today is we're just going to say, hey, these are the four, and we're just going to practice using them. Okay? So the highlights here is to prove triangles congruent. Okay? There's 4 ways. So to prove triangles congruent, what do we have now? We have S, 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 A, S. So those are the 2 that we did the last 2 classes. And then the 2 that we're going to add today are ASA and AAS. So we have 4 ways. Okay, so there's 4 ways to prove triangles congruent. And it's got to be these. And so I really appreciate how you were asking questions about the order of things, right? Because order really matters, right? So depending on the order, right, is it going to be, right, which one? Especially these last 2, right? Because they both have a pair of angles and they both have a pair of sides. So the difference between these last 2 is just where is the side? Is the side between the angles or is it not between? So just like here, right, we were looking for the angle in between. Now we're going to be looking for the side in between. So it could be helpful to draw those extra little shapes out just to really focus on that so you're not distracted by anything else. Okay? Okay. So the questions you need to be asking yourself is, what do we have? Okay, so what do we have and what do we need? Okay, so that's how we're going to get through proofs. You always start out with a list, and then we're going to ask ourselves, what do we have? What do we need? Okay, because our goal here is to prove triangles congruent. Now, we'll end up doing one of these towards the end. I just want to take a note here in the problems that we're doing. Sometimes more than one works. Oops, sorry, I'm a little off there. So sometimes more than one works. So I know in math, you guys are often told there's only one answer, which is always false. Well, I mean, there is usually one answer. Sorry, I take that back. There is one answer, but there's an infinite amount of ways to get there. Hey, I'm so glad. I hate that when Wi-Fi isn't working. I hate restarting my modem. I wish that they would just make modems that didn't have to be restarted. I'm glad you're here. So again, the triangles will always be congruent or not congruent, but there might be more than one way of getting there, right? And that's perfectly fine. So there's going to be different, right? Some people might say, hey, I used ASA, and other people might say, hey, I used angle, side. So again, either way, as long as it's correct, right, is okay. So sometimes more than one works, sometimes only one works. So sometimes, oops, that should be one word, only one works. Now, for us, the majority of the time, it's going to be that. Most times, there only one works, okay? So we have 4 ways. Usually in proofs, there's only one that works, but sometimes there's more than one works, okay? Just want to make sure you guys knew that. I didn't want to feel like I was lying to you or holding anything back, okay? So all we're going to do today is we're going to do examples together, okay? And if we participate and we work together and we ask questions, then this will go really quickly. If you guys aren't paying attention and you're playing video games instead, then we should. Yeah, I agree. So let's participate. Let's get through this. Let's do this. Great. Ask questions. And remember, I'm here for you guys. So if the lesson is confusing or the homework is confusing, you guys can always email me. You can always watch it on YouTube again. You can always come to my office hours. Okay. So we're going to start with a problem that looks like this. And I want you guys to get that down. It's not necessarily drawn to scale. Let's take a look. So I have D, G, E, F, and H. So again, not necessarily drawn to scale, just drawing a picture. So we have this shape, and I'm going to ask, is triangle EFG congruent to triangle HDG? Okay. Now, the reason why I'm doing it this way is because proofs take longer, right? So we can get through more of these if we don't do a formal proof. Okay, so that's why I'm not doing a formal proof on this one. So again, we could easily make this a formal proof. It would just take longer to do. But right, the formality you guys can do, we've done it before. I'm just going to go through the basics. So is triangle EFG congruent to triangle HDG? Okay. Oh, and I should ask why, right? Because I don't really care about the answer. I care about how you got to the answer, right? Because remember, in an argument, it's not about like what you say, it's can you back up your argument, right? So, and that's what logic is, right? It's not just like, oh, I think that stinky cheese is the best cheese in the world. It's like, why is it the best cheese in the world? Okay. All right. So let's take a look here. I'm going to update some things. So I'm going to have angle E and angle H are both 90-degree angles. And segment DG is congruent to segment FG. Okay. So again, in a formal proof, I would write these down as givens. But then the next thing I'm going to do is I'm going to write down, I have 4 ways to prove triangles congruent. So I'm going to write those down. And I'm just writing down the exact list I wrote down before. And I'm writing down these 4 to kind of like help focus me on what I need. Okay. So we have a picture, we have our givens. I have my 4 ways. So I'm going to say, are these triangles congruent? Let's take a look. Well, if these are both 90, aren't those going to be the same? Right, they're both 90. So that's a pair of congruent angles, right? So we have angle E and angle H. They're both 90 degrees. They're congruent. And then I have a pair of sides here. It looks like segment DG and segment FG are congruent. So I have a pair of sides. Okay, so now if I'm keeping stock on this, let's take a look. I'm just gonna see what I have. So I have 1 pair of sides, 1 pair of angles. So that's 1 pair of sides, 1 pair of sides, 1 pair of angles, 1 pair of angles, 1 pair of sides, 1 pair of angles, 1 pair of sides. Oops, sorry, 1 pair of sides. Ah, get that A back. Okay. I'm just gonna write this list a second time. Okay, and why did I do that? Well, because I'm lost, right? Like imagine I'm a new student, I'm lost. I have no idea what to do here, right? But just by doing this, just by saying, okay, I have 2 pieces, right? Well, I'm probably not going to be doing SSS because I only have 1 pair of sides, right? And from a laziness standpoint, I don't want to find 2 missing things if I don't have to, right? So look at this. So this means we're either going to have to find another pair of sides, another pair of angles, or another pair of angles. Okay, do you guys see how that like really focuses me? So it's probably going to be one of these 3. So I'm either going to find another side or another pair of angles. Now, remember how we took notes that first day of the trimester, right? And if you didn't, the YouTube video's up, you can take notes. Okay, so it's actually really hard to find congruent sides. Okay, so for example, do we have reflexive? You guys tell me in chat. This is what I mean by participating. So in chat, do we have reflexive? Yes or no? So if you guys forget what reflexive is when 2 shapes share a piece. Wow, so not the answers. So this is so good. I'm so glad you guys are participating because not the answers I thought I'd be getting. So, for all of the people saying yes, what piece is what part is are these two triangles sharing? That would help us prove. Okay, so G. So they share point G. So to prove triangles congruent, do we need points? Do you guys see what I'm saying? So they share point G, but that's it, right? That's the only place that they're touching. Do you guys see how they're touching right here? It's the only place. And to prove triangles congruent, I need angles and sides. So do they share any angles or sides? And I'm with you guys. It shares point G, but do they share any angles or sides? Right? Is there any overlap? Okay, so now we're having a discussion. This is really good. So, for some people who are still saying yes, the only way that a triangle would share an angle is if they were overlapping like this. You guys see how that small red triangle is on top of that big black triangle? So they share this angle. Okay, I think I drew a picture of this on the notes too. And then here's an example of two triangles sharing a side. Hey, but guys, when you say you don't really know, that's what's really wonderful is like you guys are participating. Thank you. I really appreciate you guys. So it's shared angle up top, and this is a shared side. So we don't see that in this picture, right? They share a point, but they don't share an angle, right? The angles are kissing, but I can't say angle G and know what angle you're talking about. Are you talking about this angle up here? Are you talking about this angle down here? Right? So those are two different angles. Okay, and we don't, right? So we're not using reflexive. There's no midpoint. There's no bisector. There's no isosceles or equilateral. Guys, those are the only ways we can prove sides congruent. Okay, so it's not looking, this is my workspace, right? It's not looking like we're going to do SSS or SAS. Okay, so then now I'm going to focus my energy on an additional angle. Okay, so we don't have parallel lines. Okay, because we have 4 properties that deal with parallel lines. We don't have linear pairs, though this would be supplementary. Okay, do we have anywhere that there would be vertical angles? That wasn't a rhetorical question. Okay, but we can't call them angle G, right? Because there's more than one angle off angle G, right? So no one, I haven't heard an answer yet. Do we have vertical angles? Yes or no? I need to know if you guys understand these properties. So it's a yes or no question. Do we have the setup to have vertical angles? So this is really good information. So, hey guys, you gotta so all of this stuff we're talking about now was first trimester. So we didn't, right? I didn't teach any of this stuff because you were supposed to have learned it in your first trimester class. So anytime you see an X, so if we have A, B, C, and D, angle A would be congruent to angle C, and angle D would be congruent to angle B. These are vertical angles. And we did take notes on these though. So if you guys don't have notes on these, the very first class of this trimester, we wrote down all of this stuff. You want to have it in your notes, maybe even rip it out of your notebook and put it next to your computer or where you're working so that you can look at it. Okay, so vertical angles. So do we have X's? Oh my gosh, we certainly do, don't we? There's an X right here in the middle. So that means that these two angles are going to be congruent because they're vertical angles. Okay, so I can write this down. So I'm going to have to name these. I can't name these angle G. So all that matters is I have 3 letters, so I might start with D. I might go to D, G, H. Do you guys see I'm kind of like tracing it with my pen? So you can call it either angle D, G, H, or you can call it angle H, G, D. They're the same angle. So I would say angle D, G, H is congruent. And then I take a look here. D goes with F, so angle F. G goes with G. And H goes with E, right? Because it's vertical angles. So remember, guys, all of this is open notes. So if you're like, man, I don't remember that, it's open notes. Make sure you have all this stuff in your notes so that you guys can do this, right? You guys, it's the best year to take geometry because you have everything's open notes. You don't need to memorize. Okay, so we got vertical angles here. And vertical angles are always going to happen in these bow tie problems. Okay, so we have a pair of vertical angles. So now let's take a look at this. So I did find another pair. So I found another pair of angles. So it's going to be one of these two. So now we have to figure out. So in the chat, can you guys tell me, is the side in between the angles or is the side out to the side? So you guys have to pick one in chat. Is it ASA, where the side is in between the angles? Or is it AAS, where the side is not in between the angles? So I just want to see how you guys are doing. So is the side in between the angles, or is it out on the outside? And don't put a question mark. Say it. Just go for it. I mean, it's a 50-50 guess, right? But what we're looking for is, are you guys able to tell the difference between the side being in between the angles or on the outside of the angles? Yeah. And see, when you guys are in chat, I see like all this process, right? Like, hey, and that's okay to say you don't really know. That's totally fine, right? Right? Because that tells me we need to go over it. So that's really good. It's really good information. Okay? So let's take a look at this. So when I'm looking at this, how do we know? So if you look at this angle and this angle, right, 2 angles will always be connected by a side. So the side that's connecting this is this side right here, right? And the side connecting these 2 angles is this side right here. Are these 2 sides congruent? Right? It's the side that touches both these angles. This is the side, right? This is the side in between those 2 angles. So are these 2 sides congruent? No, they're not. The side is over here. Now, another way to think about it is, do you see how this S right here touches both angles? See how it's in the middle? So it would have to be this side that touches both angles. Notice how this S right here, it only touches one angle. Well, if I look at my picture, do you see how this S only touches one angle, right? That's a really good way to think about it. And the warm-up can work like that too. So again, see how this S only touches one angle, right? So this S right here only touches, so it only touches one angle. And then here, this S only touches one angle. So again, I'm trying to find different ways to help you guys look for this, right? So AAS. So are these triangles congruent? I would say yes by AAS. Okay, and the reason, again, so maybe this will help you guys out. If you take a look at the S here, see how the S is only next to one angle. And in the picture, the S is only next to one angle. So it is AAS. Okay. I really appreciate the people participating. This is really good. I know a lot of people aren't participating. I'm worried about you guys. Okay. So, how are we doing? You guys have any questions or comments before I move on to the next one? We only have a few more examples left. Okay, let's keep going. Thank you guys, I appreciate you. All right, so let's go to example 2. Because you guys are participating, we're already going so much faster than my last period class. This is really good. Okay, so I'm gonna have Again, not drawn to scale because I'm not that accurate of a drawer by freehand. So we have a shape like this, and then I'm going to ask, is triangle PQM congruent to triangle RQM? I'm going to ask why. Now, obviously, I don't have anything written down yet, so we're just getting down the triangle. We're labeling it, and then we're asking the question, is triangle PQM congruent to triangle RQM, and why? So I'm going to add in just two things here, like that. Okay. So again, we're looking at, are these two triangles are congruent, and why? So take a little bit, think about it. Right? Is there anything we can add in? Right? And be careful, you might be tempted to add in things, right, that you can't add in. So let's just start with a general. Well, no, I'm gonna wait for a little bit. I'm gonna wait. Let you guys think a little bit more. Okay, so now tell me what you guys think. So just in chat, really quickly, yes or no, are these triangles congruent? Okay, so just in chat, what do you guys think? Yes or no? Are these triangles congruent? All right, all right. So this is really good information, guys. I really appreciate you guys. This is so good. Thank you so much. All right, so let's take a look. So first, let's take into account what we have. So I have a pair of sides, right? So I have, right, a pair of sides. Then, well, what do we have to prove triangles congruent? I have S, 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 A, S, A, S, A, and A, A, S. Okay? So if these are congruent, we got to be able to show one of these four. Oh, no, I'm so sorry. Oh, that sucks. So if I'm looking at this, where am I going to get the other pieces? Because I only have one piece right now, right? I have an S. So I need two more. So where are we going to... So help me out, guys. Where can I get additional information? So a lot of people said yes. Where can I get the additional information? I like that. From the shared side, right? Okay, so this is going to be reflexive. So I really hope that I've done enough problems with reflexive property that you guys are getting comfortable with this, right? Because reflexive property is the one thing, excuse me, that we didn't spend a lot of time on first trimester, right? Vertical angles, linear pair, spent a lot of time doing that, but reflexive property, not so much. All right, so we have another pair of S's. Okay. Is there anything else? What do you guys think? Is there anything else? I just got logged out of my email. Is there anything else, guys? Come on, work with me here. Talk. The shared side, right? So some people are questioning. They're like, I don't know. I can't see anything. A lot of people said yes. So for all my homies who said yes, it's okay if you change your mind, but if you said yes, then we had to have three pieces, right? So I hear an angle. So I'm assuming an angle. So QPM. So these two angles. So if these two angles are congruent, why? because you're onto something. Why are they congruent? And I'm really glad that you identified, because that one's a hard one. So hey guys, the claim here is that this angle down here is congruent to this angle right here. Does anybody know why? I'll give you a hint. What kind of triangle is this big triangle? We learned about this triangle this trimester. What kind of triangle is this? The big one. What kind of triangle has two congruent sides? Yeah, it's an isosceles. So by definition of an isosceles, right? If we have two congruent sides, then we're going to have these are the base angles, right? Okay, so those are the base angles. Right? We talked about that. I'm not crazy, right? We did that this trimester. Got really quiet in chat. Okay, but even with that, is this enough to prove triangles congruent? Oh no, don't worry about, yeah. Typing's hard. And don't worry about spelling. If you guys ever type something in a chat, I will never criticize you. Some people even just typed in ISO, right? So you're fine. Okay. So yeah, is this even enough though, right? So if I take a look at this, it looks like I have the angle is not in between the sides, right? It's not SAS, right? This would be angle side side. This would be angle side side. Okay, so that's ASS. That's AS. Okay. So I really appreciate this. This was really good. This is really clever. But is there any other thing to prove there? Yeah, and the answer is there's not. So we're going to say no, not enough information. And I want to just give a shout out to everyone who is participating and asking questions. This is how online class works, right? This is how we make it work. So not enough information. Okay. We just don't have enough information. Yo, I love that comment. All right. So again, guys, this is new stuff. So if you're like, oh man, I didn't get it. Good, that's where we should be, right? If you were getting everything correct, everything right, we would start to worry that you were in the right class and you should be teaching instead. Okay? So again, it's okay to struggle. Just keep asking questions and I can help you guys out. Okay. All right. Let's take a look at our next one. We have 3 more that we're going to do. So any Star Trek fans on here? Right? Star Trek fans? I didn't draw a very good one, but this is the in Star Trek, this is the symbol that they have on their chests, right? They tap to say, "Beam me up, Scotty." All right. So I got that. And then so we have again, we're going to have 2 triangles, and my question is going to be, is triangle LMP congruent to triangle NMP? And again, guys, I'm doing this format because you could totally make this a formal proof, but these are faster. So I thought we would do the faster way, right? So the Y, and when I say Y, right, in a 2-column proof, that would be your reasons, right? Like, why are we saying it? And you're going to need some information. So let's do this. Okay, so those are my givens. So let's get those down and then just take a second and be like, hey, are these triangles congruent or not? Okay, so take a little bit. So again, some people are getting their answers in. I just looked at the time. We need to get going here. Sorry, I promised a short lesson and then it went up to be longer. So in this case, are these triangles are going to be, right? Well, we're definitely, if we take a look here, right? We have two pairs of angles, right? So boom, 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 boom. So it looks like for all of these, we're going to have to find at least one more side, right? So in this one, I'd have to find two more sides. In this one, I'd have to find one more side. In this one, I'd have to find one more side. So we need to find a side, right? It doesn't look like we're going to be using SSS because we don't have any sides, right? So I want to find at least one pair of sides. So in chat, really quickly, where am I going to find that side? Where are we going to find that side? Come on, guys. Yeah, shared side, right? So this shared side, right? This is going to be reflexive. Right. MP, segment MP is going to be congruent to segment MP, isn't it? So if I have this S, this A, and this A, can you guys tell me in chat, can you guys tell me which one in chat? Which one is it? Is it going to be ASA or AAS? Oh my gosh, you guys have come so far from the beginning of this class, right? We went from a warm-up question where almost everyone got it wrong to now almost everyone is getting it right. Okay, so we're making progress. I know we're not totally there yet, but we're going to keep working on it. So if I looked at this, remember, if it's this one, the side is touching both angles. If it's this one, the side is only touching one angle, right? So we're trying to see how many angles is the side touching. So if I look at this side is touching this top angle and it's touching this bottom angle. And if I look at this side is touching this top angle and it's touching this bottom angle. So in both cases, the side is touching both angles. So it's going to be angle, side, angle. And I see people were still struggling with it just a little bit. So what you're looking for, right? If the side is touching both angles like it is in the symbol, or is it touching just one angle like it is down here? Okay. All right. So I do want to do just really quickly. Sorry, I said we're going to have a short lesson today, and then we got really into it, and we didn't. So just really quickly, let's take a look. I want to do another bow tie problem. There's a couple other problems I want to do with you here. So let's do A, B, C, and then D and E. I just wanted to take a look. So if it said prove triangle ABD is congruent to triangle EBC, what would that look like? I just want to show you guys really quickly. I'm not going to do a full proof. We'll go through it kind of quickly, okay? And this is what I mean going through this quickly, right? So it'd be statements and reasons, okay? And then I'm just going to draw in my givens like this, okay? And then in a proof, right, givens always come first. So it looks like here I'd have two givens. Again, I'm just saving time, right? Because proofs take too long. I couldn't go a whole class and not show you like how a proof setup would be. So I have two givens, right? Remember, what does the arrow mean? The arrow means parallel, right? So there was some confusion in my last class. Just because something is parallel doesn't mean it's congruent. So for example, a trapezoid is really great on that, right? So these would be parallel, but they're not the same length. Okay, so just because something is parallel doesn't mean it's congruent. Okay, so if we take a look at this, one of my givens is that I'm parallel, and then I have two segments that are congruent. So again, what are my four ways? S, 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 A, S, A, S, A, A, S. Okay, and all I have is a pair of sides. Okay, this is a problem where there is more than one way to prove the triangle is congruent. Okay, there's two ways to prove these triangles congruent, and it all depends on what angles you go for. Okay, so the first one, sorry, we're running out of time. So the first one, it's a bow tie problem, right? So you could say vertical angles. Okay, so I might say, hey, angle ABD is congruent. So I did ABD, right? You could say DBA, it's the same angle. But then what does A go with? A goes with E, so angle E, B goes with B, and D goes with C. So I could say vertical angles. And the only reason I did vertical angles is because a lot of people missed that the first time. So I just want to do another example with vertical angles. Okay. So now I have a pair of angles. And then this, our last angle, really, it changes the whole problem. Like it depends on, so it's either going to be angle side angle or it's going to be angle S. And what I mean by this, if I wanted angle side angle, wouldn't it have to be this angle up here, right? But if I chose this angle down here, then it's angle side. Okay, so again, lots of different ways to pick this, but I'm going to do angle side angle. So if I take a look at here, do you see how I have parallel lines? Well, this angle right here is going to be congruent to this angle right here because they're alternate interior. So I can say here, angle C is congruent to angle D, and my reason being, if parallel lines, then alternate interior angles are congruent. Okay. So we have alternate interior. Do you guys see how the angles are on the inside of the parallel lines? And we have a transversal here, and they switch sides. Okay, so that's my reasoning. Okay, they're inside the parallel lines. They switch, right? One here's on the top of the transversal, the other one here's on the bottom of the transversal. So these are inside and they alternate, so they have to be congruent. I realized that I picked up the pace a little bit. I thought that today was going to be a short lesson. It wasn't. I'm so terribly sorry. And then we would end this. Right, I didn't mean to lie to you guys. I didn't do that on purpose. Okay, so I would say, why are they congruent? So in this case, I can say angle side angle. But remember, E and A could also be alternate interior. Okay, so it's alternate interior this way as well. But if I had picked A and E, then it would have been angle side. Okay, so I just wanted to show you guys an example where there's more than one way to show that the triangles are congruent, right? So in this case, with the work I used angle side angle. But if I had picked these two angles up here and down here for alternate interior, then it would have been angle side. Hey, we're going to run out of time, but I want to do one more because I do feel like the more exposure to these problems you have, the better you're going to be able to problem solve and not feel like I can't do this. I'm going to do one more really quickly. And I'm so sorry about this, guys. I know I'm going a little fast. But here's the last one. Okay? And here's the last one. Okay? So I'm just going to... it's basically almost a rectangle. Oops, a rectangle. Let's call this H, F, G, and K. And we're going to prove triangle HFG is congruent to triangle GKH. One thing I'm really looking forward to our new schedule is that we'll have 5 more minutes together. And then I'm going to say this is 90 degrees, this is 90 degrees, and this is parallel to this. Okay, so I know I'm out of time, so I can't do a full proof. Okay, but I do want you to notice that we have a pair of congruent angles here. In the middle, right, we have reflexive. So there's apparent sides. And then with parallel lines, right? With if parallel lines, then I would have, do you see how this angle touches this parallel side? And this angle touches this parallel side. So this would be alternate interior angles again. So in this case, it's not going to be SAS. What do we have? We have two pairs of angles, and the side is not in between the angles. So in this case, it would be angle, angle, side, right? So I'm just going to just really quickly, I would write it like this. I'm just going to write out all my steps. So this is reflexive. And then angle FHG is congruent to angle KGH. And that's if parallel lines, then alternate interior angles are congruent. Okay. And it's angle, angle, side. And we can do this because check out how many angles is the side touching, right? So if I look at just this bottom triangle, this side is only touching one angle. If I look at this top triangle, this side is only touching one angle. So I'm going to pick the one that has S only touching one angle. Okay? Guys, I am so incredibly sorry that I promised a short lesson and then I took more of your time. Please remember, if you need help on your homework, I am here. Email me, come to my office hours. I want to help you guys. You guys are not in this alone. I am here to support you. Please communicate with me and I'll help you out.